What we see here is the spec-driven development using speckit. Here I have a research. This is just a dump CLI app that prints the weather temperature of my city. So using the speckit commands, it generates whatever markdown needs to generate. And here in the spec, like we have the regular user story, the acceptance criteria, given when then, and what requirements this story covers. And here we have this section. This is the addition from my side in the framework that I'm looking for a verifiable scenario in this form, so I can do BDD basically. So for every user story I have this verifiable scenario, and what the framework is doing, it is creating a plan, tasks, and also it creates this this model JSON. So this is what I was missing. This is like this map that has all the requirements here. It has all the scenarios, so it has like the user story. For this user story we need this acceptance criteria, and here is the BDD test. For the other user story we need this acceptance criteria, and we have this test, and this is actually the spec. This is what I like. So from this JSON the framework generates the verification.feature, which is a file that I'm using in Golang for a very old framework called Godog, which is like something that comes from Cucumber. Now it's deprecated, but it does the work for me. So this is a copy. So for example, if I look for this in the spec, I should be able to find that. So you see like this one-to-one coming from the spec, but the important thing here is not a markdown file. This is a .feature file, which means it is getting parsed from the BDD framework that I'm using. And what it's doing, the framework is generating from that file, and it's basically parsing line by line. So for example, this is for that line, this function, the other is for the other, this one, and so on and so forth. So this is done programmatically. There is no any LLM involved here, but what is happening is that every function here originally is empty. So the LLM is supposed to write the test, so all of the tests are failing by default, and the LLM has to write the tests. So as soon as you do this, okay, then you can run the speckit command. In that case, you have to pass the specification, and I have created this BDD flag, which is creating again all of those files. So when I'm running this, it is running the tests. Now, of course, the tests are populated already, and they are passing. But it's pretty nice because if something fails in here you see the report either in JSON or in Markdown. You see what is passing and what is not. But also what is really cool is that you can also run the framework by itself, go test run, and here you see exactly line by line. Green means pass, red means failed. So everything is passing here, but if you see a line that is red, then immediately you know what part of the spec is failing, where that line is in the spec. So for example, let's say that this is failing, okay? This is exactly coming from the spec. So if I go to the spec, here I can immediately see, okay, this is the line that is failing. That's part of user story 1 and covers these requirements. So of course the LLM is gonna write the test, and it might try to trick us by making the test pass, but at least I don't need to trust the fact that this test is related to this user story. The test is programmatically bind to the user story. That is the whole feature I'm talking about here.